Good day everyone! Welcome to the world of mathematics. So in this video, we will learn important things and those are about pre-calculus and basic calculus. So math is not that hard actually. So don't be discouraged or confused right away because I am here. Teacher Ella will help you understand each lesson in this subject. So without further ado, let's start our discussion.
Okay, so we're down with the last lesson for this quarter, which is about Pascal's triangle and binomial theorem. So before that, let's have first again our daily reminders. Again, if you think that you can understand the lesson because it's too fast for you, you can pause it for a while, then think about the solution or think about the slides, then you can again play to proceed on the discussion. And also, much better if you have your ball pen and notebook with you so that you can jot down the important notes or formulas that we can use in solving problems involving our today's lesson. So let's start. Again, our lesson is about Pascal's triangle and binomial theorem. So let's have first objectives. Number one is to analyze the different patterns in Pascal's triangle. Number two is to solve involving binomial theorem or solve problems involving binomial theorem using Pascal's triangle. And number three, actualize creativeness in finding solutions to every real-life problems. Okay, so we're down with the last lesson for this quarter, which is about Pascal's triangle and binomial theorem. So before that, let's have first again our daily reminders. Again, if you think that you can understand the lesson because it's too fast for you, you can pause it for a while, then think about the solution or think about the slides, then you can again play to proceed on the discussion. And also, much better if you have your ball pen and notebook with you so that you can jot down the important notes or formulas that we can use in solving problems involving our today's lesson. So let's start. Again, our lesson is about Pascal's triangle and binomial theorem. So let's have first objectives. Number one is to analyze the different patterns in Pascal's triangle. Number two is to solve involving binomial theorem or solve problems involving binomial theorem using Pascal's triangle. And number three, actualize creativeness in finding solutions to every real-life problems. So let's define what is Pascal's triangle. So Pascal's triangle was originally developed by the ancient Chinese, but Blaise Pascal was the first person to discover the importance of all the patterns it contained. And this is an example of Pascal's triangle. So actually, Pascal's triangle has different secrets. We have different techniques that we can use or the different techniques that we can use in the Pascal's triangle. Ay, ay, ulit. Dito na lang. Okay. So Pascal's triangle was originally developed by the ancient Chinese, but Blaise Pascal was the first person to discover the importance of all the patterns it contained. Actually, Pascal's triangle is like a treasure hoard. It has many secrets that we need to find. Okay? And there are many uses of the Pascal's triangle. And one thing or one cool thing about this is we can use this in binomial theorem, meaning we can use the Pascal's triangle as a shortcut in expanding a given binomial. So as you can see here, we have the Pascal's triangle. How start with 1, then 1, 1, 1. Once we have the different rows, in Pascal's triangle, we will start the counting of rows by 0. So the tip, which is the top, is this is the 0 row, this is the first row, this is the second row, third row, fourth row, and so on. Again, in Pascal's triangle, we will start the counting of rows by 0. And Pascal's triangle, again, as I said earlier, we can use this in expanding a binomial. Okay, we can use this as a shortcut. So we have here, let's say for example, the binomial x plus y then raised to n, wherein n is the number of exponent, or it can be the number of rows in the Pascal's triangle. So each row corresponds to the coefficient of the binomial expansion. So let's have the steps in expanding a binomial using the Pascal's triangle. Number 1 is to get the coefficients from the row of Pascal's triangle according to the given power or exponent. So let's say for example, going back to this one, let's say the exponent given is 4. Let's say for example, it's 4. So we will find the fourth row. Again, the counting of our row is start with 0. So 1, 2, 3, 4. Or 1, 2, 3, 4. So this is the fourth row. So meaning we will get the coefficients of the fourth row. When we say coefficients, the number that you can see here, so we have 1, 4, 6, 4, 1 as the coefficient. Okay. Then step number 2, going back to the steps, is identify the first term. It's really important to identify the first and last term. Okay. So after identifying the first term, always remember that the power of this is will start with the highest exponent and it will decrease. And number 3, identifying the last term, because the last term, the power of it will start from 0 and it increases. Right? So as you can see, there's an opposite here. So in first term, the note or the power starts with the highest exponent and it decreases. While the last term, it starts with 0 and it increases. Then last step is we will add and simplify all the products of the coefficient, the first term and the last term. So let's now have the real life example. So problem number 1, Ariel's result has a square-shaped private pool. Each side measure x plus 8 meters. So question 1 is how can you find the amount of water needed in the pool? Question 2 is what is the formula needed in this problem? Question 3, how much water is needed to fill the pool? So later we will explain the answer in each question. But first, like I've said, or like I've always reminded you that in every word problem, we need to analyze it first. We need to find the given. Okay? Again, in problem number 1, the given here is we have a square-shaped private pool. And we have each side, they have the same side or they have the same measure of the side, which is x plus 8 meters. Now, let's proceed to question 1. So how can you find the amount of water needed in the pool? Since the problem is about the amount of water, we can conclude that we will going to find the volume of water that can fill the pool. So meaning, in finding the volume of the water, we need to use a formula in finding the volume. So in this problem, we can say that the pool is a cube shape because they have the same measure. Each side has the same measure, which is x plus a. So therefore, we will use the formula in finding the volume of a cube, which is V is equal to S cube. Wherein again, the S is the measure of the side. So using the volume, we will now start to compute the volume of the pool or the amount of water to be filled in the pool. So using the given, we have here x plus 8 meters. So this is the side. Now, first that we need to do is again, we need to get the coefficient to or coefficient from the row in the Pascal's triangle. So since going back to our formula is volume is equal to x or s cubed. So meaning our highest exponent is 3. Meaning we will get the coefficient of the third row in the Pascal's triangle. And that is 1, 3, 3, 1. So after that, we need to determine the first term. So x is the first term, 8 is the last term. Always remember that in first term, our exponent will start at the highest exponent. So this time, this is 3 as the highest. So our first exponent first term will start at cube or exponent 3. While our second term will start from 0. Okay? So we have typo again here. This is x plus 8, x plus an early typo for this lesson. Okay, so x plus 8 cube. And as you can see here, the coefficient. So here is the 1, 3, 3, 1. So these are the coefficients or coefficient from the Pascal's triangle from the third row of it. Okay, so 1, 3, 3, 1. Now we will plug in the first and last term in every coefficient. So this is the first term, the second term, and as you can see, first term again, second term, first term, second term, first term, second term. Then going back to this one, our first term will start with the highest exponent. So the highest here is 3. So 3, and as you can see here, the second one becomes 2, becomes 1, and becomes 0. Right? Then, with the second term, according to this, we will start with 0. And also, according to the steps earlier, we will start at 0 exponent in the second term, but it increased or it will increases. So from 0, as you can see, we have 1 here, 2, then 3 at the end. Okay? So we will just simplify. So we have x cubed, then 8 raised to 0 is 1. Again, always remember that anything that raised to 0, the value is 1. So we have 1, copy plus 3, then x squared, then simplify 8 raised to 1 is still 8, plus 3 times x raised to 1 is x, then 8 squared is 64, plus 1, then x raised to 0 again, anything that raised to 0, the value is 1. Then 8 raised to 3, that is 512. Then after that, simplify again. So x, 1 times x cubed times 1 is 1x cubed. Next is this one, 3x squared times 8, we have 24x squared, plus 3 times x times 64, we have 192 or 192x. And 1 times 1 times 512, that's 512. So we will just simplify again. So since this is 1, so we can write it as x cubed. Then 24x squared plus 192x plus 512. So the volume of water that is needed in the private pool of Ariel is x cubed plus 24x squared plus 192x plus 512 cubic meters. So as you can see, instead of multiplying x plus 8 to x plus 8 again to x plus 8 again, we can use the Pascal's triangle to shorten the time of computing the volume or computing the exponent of a certain binomial. Okay, let's have another example. So in problem number 2, using the Pascal's triangle again, expand a plus b raised to 6. So we have higher exponent than the problem number 1. So again, first thing is we need to find or get the coefficient of the sixth row. So we have again type here sixth row. And the sixth row of the Pascal triangle has the coefficients of 1, 6, 15, 20, 15, 6, 1. So we will just write it down. So we have 1, 6, 15, 20, 15, 6, and 1. So we already plug in the coefficients. Now let's proceed to the first term and second term. So the first term is a, so therefore from a, our exponent will start from 6 and it decreases. While the second term is b, therefore the b or the power of b will begin at 0 but it increases. Okay? So from a, again, this is the first term, so we will start from the highest exponent. So this is 6. Again, we have typo again here. This is 6. Okay? From the given, that is a plus b raised to 6. So let's have first the first term. Right? So from 6 becomes 5, becomes 4, becomes 3, becomes 2, then 1, then 0. Again, as you can see, the first term, the power of it will start from the highest exponent and it decreases until 0 exponent. Next is the second term will start from 0 but it increases. Okay, so b raised to 0 becomes b raised to 1. Then b raised to 2, b raised to 3, b raised to 4, b raised to 5, and b raised to 6, which is the highest exponent. So after that, simplify. So a raised to 6 times b raised to 0. So b raised to 0. Okay, so let's change the color of our ball pen. So b raised to 0 is 1. So 1 times a raised to 6 is a raised to 6. Next is a raised to 5 is a raised to 5. Then b raised to 1 is, we can say that as b. Okay, so imaginary exponent, which is 1. So a raised to 5 times b raised to 1 times 6 is 6 a raised to 5b. Now let's proceed to the third term. So we have a raised to 4, b raised to 2 times 15. So that's the answer. Next, the fourth term is 20 a cube b cube. Next is 15a squared b raised to 4. Then this one, so a raised to 1, we can write it as a since imaginary 1, our exponent here, and a, then b raised to 5. So 6a b raised to 5, and the last term is 1 times a raised to 0, again anything that raised to 0 is equal to 1. So 1 times 1 is 1 times b raised to 6, we have b raised to 6. So therefore, the answer for the quantity of a plus b raised to 6 is a raised to 6 plus 6 a raised to 5b plus 15a raised to 4b squared plus 20a cubed b cubed plus 15a squared b raised to 4 plus 6ab raised to 5 plus b raised to 6. So as you can see, we can easily find, or we can easily expand a given binomial even if the exponent is in the highest value, right? We can use Pascal's triangle to again shorten our time in calculating or expanding a given binomial. Now, let's proceed to the last problem, I think. So what if, teacher, we have our first term, we have numerical coefficient already, and our, unlike the problem 1 and problem 2, the operation there is addition. While in problem 3, we have here minus, right, or subtraction. So same process. We will, again, we have type again here. Again, if what is your, or if your exponent is 4, therefore we will get the coefficient of the fourth row. Okay, be careful with that. So if the exponent is again 4, we will get the coefficient in the fourth row of the Pascal's triangle. But again, in Pascal's triangle, the counting of the row will start from 0. So literally, we will get the fifth row. Okay. So the coefficient of the fourth row is 1, 4, 6, 4, 1. And again, we will identify the first term here is 2c. So we have 2c. Then, as you can see, we have subtraction here as the operation. So we will conclude, or we will use the minus as the sign of our second term. So our second term will become negative b. Okay? So since the highest exponent is 4, the first term will start, or the exponent of the first term will start from 4, then it decreases. While the second, which is b, okay, just don't mind this one. You have again the typo here. I will just said, or I will just say what are the steps. Okay, again 2c is our first term. So the exponent of our first term will start from 4, then it will decrease. Then our second term, which is negative d, will start from 0 and it will increase until exponent 4. Okay, so we will just plug in the coefficient first. So 1, 4, 6, 4, 1. Then after that, we will write the first term. 2c, 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 2c. Then after that, we will write also the second term. So don't forget the negative sign. So negative d, negative d, negative d, negative d, and negative d. Let's now apply the exponent. Again, when we say first term, the exponent will start from the highest exponent, which is 4. And it decreases, so becomes 3, becomes 2, becomes 1, and 0. While the second term is again will start from 0 and it increase. So from 0 it becomes 1, 2, 3, and 4. Right? Then after that, we will simplify this one. So don't forget that if the given has a numerical coefficient, distribute also the exponent to the numerical. So meaning, we need to raise the numerical 2 to the fourth power also. So meaning 2 raised to 4, that's 2 times 2 times 2 times 2, that's 16. Okay? Again, if we have given numerical coefficient, raise it to the exponent also. Then c raised to 4 is c raised to 4. Then again, anything that raised to 0, the value is 1. Last, again, we have 2 as the numerical, so we will raise it to 3. So that's 8. Then c raised to 3, we have c cubed. Then negative d raised to 1, we have negative d. Another thing is, if our given is negative and it raised to an odd number, the answer will be negative. But if the exponent of a given negative number is even, the final answer is in positive form. Okay? So as you can see here, 1 is an odd number. So therefore, our negative d is still negative. While here, let's have first this one. So 2 raised to 2 is 4. C raised to 2 is c squared. Then, like I've said, negative t raised to 2. So our exponent here is even number. So therefore, our answer will be in positive form. So d squared. Okay? The next one, 2 raised to 1 is 2. C raised to 1 is c. Then again, we have here the exponent is odd. So meaning our answer will be in negative form. So negative d, then the exponent 2. Okay? Then 2c raised to 0, again anything that raised to 0, the answer is 1. So 1, and again, the exponent of negative d here is even. So our answer is in positive form. So d raised to 4. Okay? Simplify. So 16 c raised to 4 times 1 is 16 c raised to 4. Times 1 again, the same. 16 c raised to 4. Now we have this second term. So 4 times 8 c cubed, we have 32. Okay? So we have 32 c cubed. Now multiply it to negative t. It becomes negative 32 c cubed d. So the operation here is subtraction. We will put minus. Next term is 6 times 4 c squared is 24 c squared times d squared. We will get 6 or 24 c squared d squared. Okay? Now let's proceed to the second to the last term. 4 times 2c is 8c times negative d cubed. We have 8 8c or negative 8c d cubed. Okay. Again, we have typo here. This is 8 instead of 8. Negative 8c d cubed. And last one, 1 times 1 is 1 times d raised to 4 is d raised to 4. So therefore, the final answer here is, okay, so let's erase the 2. Again, the final answer is 16c raised to 4 minus 32c raised to 3d plus 24c raised to 2d raised to 2 minus 8cd cubed plus d raised to 2. So that's it. Again, always remember that in expanding a binomial using the Pascal's triangle, the first thing that you need to do is to get the coefficient from the Pascal's triangle from the row. Let's say, for example, your exponent is 4, then get the coefficient in the fourth row. But again, we will start from the 0, okay? The counting of the row will start from 0 in Pascal's triangle. So literally, you will get the fifth one, okay? And next step is determine the first term. Second is the determine the second term or the last term. Then after that, plug in all the coefficients, plug in the exponents, then simplify. And that's it. Okay? All you need to do is practice so that you can easily answer some problems or every problems. Okay?
Hopefully, you really understand our today's lesson. So don't forget to practice more so that you can fully understand our today's lesson. And also, don't forget to attend your synchronous class for more examples and real life problems about our topic for today. So thank you for listening and see you on the next video. Bye!